Good morning, everyone. Good evening,
Yes.
good afternoon. Today is the second episode of Groundbreakers Transforming Geotech, and I'm honored to have Dr. Joel with us. Dr. Joel is a pioneer in the GNSS field, and he has been doing really cool inventions in this field, such as the monitoring of the verticality of the Burj Khalifa. He worked on developing the module at Leica for GNSS, and now he's making really interesting millimeter level precision GNSS modules. And he's been involved with several other projects globally. So it's a pleasure to have him here today. And it's going to be a great learning experience for us about how we can use GNSS and the value of this tool in monitoring, surveying, and civil engineering. Dr. Joel, do you want to add anything to the introduction?
No, thank you so much. No, you have been very completed and very kind. And it's true that over probably 35 years from now, I've been involved and I've been very much interested by engineering geodesy and the applications on monitoring. One of the reasons is that this field of applications is still very demanding in terms of accuracy and reliability on the result, which is exactly what geodesy does. Sorry, and that's true that I started with the total stations, automatic total stations, with dual axis inclinometers, and then GPS at the time pop up and GNSS now. And interesting thing is that despite the GPS and GNSS have been developed mainly for defense applications, the scientist community did really very interesting and amazing development, looking for millimeter accuracy. And probably the very first applications that they were looking for was on geodynamic to look if GPS at the start would fit with the plates boundary monitoring. So all about plates worldwide. And they got very early amazing results. I mean, we were on the millimeter level, which fit exactly with what the geodynamics people were expecting. They were using before, all the satellite resource and also the astronomy to do that. But GPS really breaks through with this amazing performance. And from that time, of course, another community of professionals were also looking to use GNSS and GPS and GNSS. And it was, of course, the geodesy and surveyors. And they were all the time looking to get this accuracy, this tremendous accuracy, coming from several centimeters down to the millimeters. And obviously, GNSS is the perfect answer for many problems that we are encountering in deformation measurements. And there are several reasons for that. The system is fully automatic. It's working 24 hours a day, 7 days a week. You just need proper telecommunications and a power supply and basically internet GNSS receivers. Doesn't need to be calibrated, doesn't need to be upgraded so far. So this is a system that fits very well, and also totally immune from all the weather conditions, and especially for critical monitoring applications, when it's about dams or it's about bridges, long bridges. The engineers who are in charge of these infrastructures are really looking the behavior of the infrastructures during the bad time.
Yeah.
You know, it's just when you have typhoon, when you have heavy rain, long rain falls, that people are starting to be concerned. And the other the other method that we are using in geodesy, I mean, robotic total stations,
Yeah.
LIDAR, laser scannings, whatever, are really suffering about weather conditions, extreme weather conditions.
Yeah.
And then, you know, I start really to be involved in that field of applications. I was working at the National Geographical Institute in Belgium, and then I moved on a different place, but all the time keeping in mind that GNSS is a perfect tool for monitoring applications.
Yeah.
And you have a lot of applications that can be covered by GNSS. The interesting thing is it's not only looking for three-dimensional displacements, which matter a lot, but also because you can map these three-dimensional displacement into the frequency domain. And then you get the structural engineers who are very much interested for bridge applications. And we work with the University of Nottingham at the time when I was also vice chairman at the Commission 6 of the International Federations of Surveyors. And we did a lot of investigations about how we can use the GNSS output, not only the three-dimensional displacements, but also to map into the frequency domain and compare with what the traditional sensor, like the three-dimensional accelerometers and interferometer, can do the job. And it's true, as you mentioned, I've been very fortunate to be involved in this high-rise building adventure, starting with the Burj Khalifa, and again the combinations of GNSS, high precisions with other sensor demonstrate that how well it fits with this kind of extreme engineering. So yes,
So
you
it's
cannot
been
ask me. You cannot ask me about GNSS for monitoring and giving a short talk.
yeah. Yes, I think even when we met a month ago in Lucknow, the technical background that you have was really, really, really like I was wowed. And I think the applications, as you mentioned in the previous few minutes, really expands all over, especially for critical monitoring of bridges, dams, mines. I remember we talked about coastal seawalls. But over your time, what have been like 3 or 5 of the big factors that have helped this technology mature to the point it has so far? Like, what were your wow moments?
Yeah. You are very right to ask that questions, because there is a breakthrough, you know, in the adoptions of GNSS for monitoring. At the start, I mean, sorry, 10 years ago, 10 years ago, 10 years, 15 years ago, there was a paradoxal situations where the people agree that the GNSS was definitively the amazing tools to do the job. But on the other side, the equipment was costing significantly a lot. And then you get on these situations where you complete this project and the budget couldn't fill, you know, to cover the investments on GNSS receivers and antenna. And that has been really the paradoxal situation, because the people were asking for the high accuracy, high reliability, and they were also asking for an affordable price for the equipment.
Yeah.
On the other side, during the last 10 years, new constellations pop up. This is the reason we are talking about GNSS, the Global Navigation Satellite System, instead of only the GPS, which is the development made by the Department of Defense of the United States. So we got the GLONASS from the Russians, we got the Beidou from the Chinese, and Galileo from the European community. And then all these constellations, sorry, with new frequencies. That's a lot of satellites, a lot of information. And then this the breakthrough happened really 10 years ago, where companies like a Common Technology in China start to develop their own board. And then the price, of course, changed significantly. And this is what is happening with the chipset industry as well today. If you read the news, you will see the progress in the chipset industry is tremendous. And the outcome is that the price is going down and down and down. Then we are in the situations today where we can perfectly answer a project owner, the people who are looking for having a solutions to answer the problem. Because now the hardware and the hardware for the receivers and the hardware for the antenna are just perfectly high quality in the observations, and also in the software, which is very important with GNSS. And then, with these two factors, we can really answer high accuracy, high reliability, and an affordable price, which would change considerably the problem. I think that it took really probably 10 years, and a lot of universities and academics were researching for 15 or 20 years to look for the low cost receivers. But the low cost receivers, as we are understanding today, cannot deliver this high accuracy. So you really need to have a game changer who is bringing, the best out of the GNSS signals, but for an affordable price. And I think that this is the reason why today GNSS must be unresistible.
Yeah. I think I like that because you gave a brief overview on how the technology is matured, and it was the launch of more constellations, it was the high accuracy coming in, and it was also, I think, now the power of data analytics and data intelligence that you can bring in with what you're getting from the GNSS, raw data to actually empower people. Like, this is what it's actually doing, and it's just not a high accuracy um, system, and it's now reliable and cost effective too. So hopefully, as we progress and traditional instrumentation also becomes more valuable, GNSS comes in as a big playing factor in the future, as it has been for surveying. So my next question would be, could you talk about one or two projects where GNSS actually changed the perspective of the owner of the asset, or one or two projects where you got a lot of insights and learning on the value of GNSS?
Oh yeah. I would say that, of course, we could talk about a high-rise building, but it's mostly in constructions, and also the monitoring, the long-term monitoring after constructions. I mean, this is the decennial responsibility of the contractor, and GNSS is definitively, the to measure the deflections of such a high-rise building, complemented with dual axis inclinometer, accelerometer. You have all the geotechnical sensor that can be blended, but GNSS is definitively what people are looking for. So this is for the high-rise building. Now for the bridge, I've been also fortunate to participate to a lot of projects, the Stone Bridge in Hong Kong, and then several long bridges in China and even in Europe with the viaduct of Normandy, the bridge of Normandy, and the
Wow.
viaduct of Tancarville. So yeah, so and really many projects where I've been involved for designing the solutions and to bring the complete solutions. And also for bridge today, there is no point. The people recognize easily the value of using GNSS. And then probably a project that underlines the role of GPS, the GNSS, sorry, was the Four Dams project that we got when I was working for Leica for the Ukraine energy. So
Yeah.
this is a four hydropower station, three on the Dnieper River and one on the Dniester River. The people learn with the actually with the news today. And on these four projects, we design a completely innovative solutions, hybriding GNSS with automatic total stations. And the evidence of the solutions um, was that during the foggy times, foggy weather, for the heavy rain and snow, and you can imagine that along those large rivers,
Yeah.
you get a lot of different weather conditions. I saw myself, the robotic total stations stopped working because cannot measure on the reflectors anymore because
Yeah.
of the weather conditions. And GNSS still giving and delivering the data. And I think it's very important because again, I mentioned that before, but the people who are looking for critical missions and monitoring, so not the people who are interested to learn, to gain knowledge on an infrastructures, which is perfectly respectable, but this is another goal. But the people who are looking for critical missions, GNSS is a perfect tool because
Yeah.
it is being designed to work 24 hours, 7 days, all weather conditions, days, nights. So
Yeah.
this system is really, I would say, very, very robust
Yeah.
and accurate for this kind of critical missions. I've been also involved in a landslide monitoring project, exactly the same. You know, a landslide is triggered by the rain,
Yeah.
basically. So you have, of course, all the source mechanics context, but basically this is the rain who is the trigger. And when it's rain,
Hmm.
GNSS is working.
Working. Yeah.
The,
Yeah.
the sensor will have much pain. You know,
Yeah.
we can do a lot of interesting things, even for structural engineering using a radar, you know, this new technology.
Yeah.
But at the end of the day, if the people are concerned about the safety of the infrastructures, GNSS is the real tool, you know,
Yeah.
without any contestations.
Yeah.
And the the way we are evangelize, we are, you know, making the promotions of the use of GNSS for monitoring is very straightforward.
Yeah.
Often the people, you know, who are not really aware about the performance of GNSS at the millimeter accuracy level, we offer to the people to demonstrate. I mean, this is a part of our job
Yeah.
to set up this proof of concept and to show the people how it works. There is no magic, there is no mystery. You know
Yeah.
that's better than me. This is monitoring, this is communication, this is power supply, this is setup, this is handling the data, and then you just can show the people and even demonstrate displacements.
Yeah.
And all the time we did this exercise, the people were very surprised. You know,
Yeah.
they really agree about that.
Yeah. So I think it's
So
a tech. Yeah. Yeah. So it's like a technology which is so good that you have to actually see it to believe it, and it's very robust and reliable as well. And I think on the projects that we worked with you, we've been seeing that on the dams and hopefully on the big bridge as well, where we have a record-breaking installation. The value of GNSS will come in. So my next question to you would be for someone who is new to the geotechnical field and monitoring field, and they don't really know what a GNSS is. How would you explain it to a new person in the field, very briefly? Wait, did I zone out?
Yeah, basically, this is also one of my talk is that the geotechnical monitoring people and the geodetic monitoring people must talk each other. I saw that in high-rise constructions where the people were asking me about leveling, the basement, the ground floor. And I was just wondering, okay, we can do that. We can manage by digital levels, whatever. But you should have, geotechnical sensor as well, like extensometer, piezometer. You should have this. And the people say, yes, we have. We have plenty, in fact. And then I came with the idea, but why not, to set up the link, to at least survey things that is sense in order to combine these both worlds. I saw that also on Wan Chai bypass, it's a big project in Hong Kong, where they are reclaiming the land over the sea. And we have a massive installation at the time with robotic total stations and prism, like a massive development of prism. And the people were asking me, can you add some points here and there? And I just realized that we were very close to extensometer, strain gauge, a lot of geotechnical instrumentation. And then I really advocated people, please talk each other. It cannot be a split, geotechnical and geodetical. We have to do hybridations. We have to combine both. So for geotechnical people who are not really aware about the performance of GNSS, I would say this is, the signals that we are using. We're using the carrier phase measurements on the signals. It is a very short wavelength by 12, 18 centimeters. The physics is just telling us that the accuracy of the carrier phase can be, of course, millimeter and eventually sub-millimeter by using filtering techniques and digital signal processing. So we are using, signals with very, very accurate. Of course, this signal is coming from the space, 20,000 kilometers away, hitting the ionosphere and the troposphere. But there has been tremendous development to figure out how we can retrieve all those effects, eventually correcting the orbital's error. So we benefit, from a huge development. And interesting enough, it's academic developments by science. So the result is easily open, and we benefit of all those developments to make GNSS as accurate as it is today.
Yeah.
One time, just as a story, I was talking with Chris Ritsos, who was a professor at the University of New South Wales in Sydney, in Australia, who is now becoming a chairman for the UIG associations, and he was asking me, hey Joel, what would be the next challenge for GNSS? And I told him sub-millimeter accuracy, and it just reacted by saying impossible.
Yeah.
And I told him, come on, everyone was thinking it's impossible to fix centimeter accuracy with GNSS in real time. And this is what most of the surveyors on the planets are doing. And
Yeah.
then I thought twice, I say, yes, you're right. We have to challenge more. But
Yeah.
just to say that the technology is available, it's long-term proof. And what we are using for monitoring projects is used on a daily basis for surveying.
Yeah.
So what we do is just changing the way we are doing the processing. Also, taking the advantage that we are not in a necessarily high dynamic environment. So we
Hmm.
can set up the antenna where, of course, it matters. But we also take care about that, which is
Yeah.
a totally different pictures with surveying,
Yeah.
actually.
Yes.
For monitoring project, the bridge is quite open, the tower is open, the dam is large, you know.
Yeah. 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 So I think we have a little bit more time, so I could ask you my last question is that where do you see this going in the future? And as we've seen in the past 35 years, you've seen it actually mature from a GPS to being sub-millimeter level and surveying. People are using it every day. It's coming into monitoring. GNSS and drones with RTK. What's your vision?
The vision is, we it's interesting because we are still looking for more, you know.
Yeah,
We are still looking for more. I told you that there is a gap that we bridge because high accuracy and affordable pricing. And I am very sure that we can keep developing, researching, and getting more and more affordable the technology. We are already on this OEM board on the chipset. The development is absolutely stunning to see how we are going to miniaturize the chipsets, the core module of OEM board GNSS. And I believe that much can be done to specifically address the monitoring conditions and
yeah,
monitoring environment. 10, 15 years ago, 20 years ago, most of the company who were manufacturing GNSS receivers were just taking the same gears for surveying and say, this is for monitoring as well, this is for cores, this is for everyone. But the hardware was exactly identical. And then we can take advantage, of course, of the monitoring conditions to figure out how we could make it compact and also to open more the interactions uh, to, this IoT. We
yeah,
are talking about the Internet of Things, which is also closely related with monitoring because it's about a massive deployment of sensor to get the response from the sensor and eventually to do retroactions with actuator. So I think that there is still a lot of things that can be developed and can be really innovated in that field. I'm just thinking about the data format. We are using in GNSS the entry protocol, which is
yeah,
done well to make it longer, but this has been tailored for surveyors, for surveying. And on the other side, for the IoT, we have this MQTT data transfer and protocol, and there's still different worlds, and those different worlds is to match. Regarding geotechnical sensor, we can perfectly do the hybridations. If you cannot put the GNSS antenna exactly where you want,
Yeah.
okay, the setup of the GNSS receivers difficult. You can use an extensometer. You can use other geotechnical device to propagate, to offset the coordinate, and at least for the structural engineering, so structural monitoring, the key question, is the people agreed to get the mass of data. We are living in the massive information society, and the way to represent the data or to integrate the data, at my opinion, should be in the BIM. BIM is the platform that we are using in the constructions. But you have companies who are developing BIM for infrastructures, for bridges, for dams. So BIM is progressively going everywhere. And I believe that monitoring data, sorry, must also be integrated in the BIM. So you see, we have the perfect tools, but now we have to make it works all together. And I think that the hybridations, making the sensor very much compact, still looking for high accuracy, high reliability, is really the features development. And we are looking for that.
Yeah. I think to sum it up, GNSS has moved on from the GPS that was invented by the United States Defense Department to now being a sub-millimeter level accurate, robust, and reliable system that we can use in surveying, monitoring, and more. And data intelligence is becoming more and more paramount. And Procure is a tool that we're developing to help with that as well, with the BIM, the 3D model. And I think it's been a great conversation, and out of my experiences, just getting to know you, there's never a time limit to gain knowledge from you, and we can spend more and more and more time talking. And thank you so much for your time to come on to the second episode. And I think people will gain a lot from this and a lot of value. And I look forward to having you again in the next year or two, or hopefully even faster, to see like, this is what we talked about 2 years ago, and this is where it is now. And let's move the world together with getting new technology into our field and empowering civil engineers to make a change. Thank you so much.